In our previous video, we saw that as the load decreases, the regulator reaches its operating range limit. Its range can be increased by changing the series resistor Rs. I am Reshma, and in this video, we will see how this resistor can be calculated. Today, we will learn about Zener calculation of series resistor Rs, Zener calculation of its circuit parameters. Let the output voltage be 5 volt while the input range is in between 8 volt to 30 volt. Let us assume that the maximum load that can be applied for this is 1 amps. This means Rs should be low enough to provide enough base current at low input and maximum output conditions. We can calculate the maximum load resistor as R2 is equal to V out by IE. That gives us 5 ohms. Let us first assume that the Zener is not present in the circuit. Now, with this, Is is equal to Ib. With a load of 5 ohms, required Ib can be calculated. We know that IE is equal to Ib into 1 plus beta. Then, base current is given as IE by 1 plus beta. This results in 9.9 milliamps. Let us apply KVL to the circuit. Vin minimum is given as IBRS plus VBE plus Vout. With minimum input voltage, Rs can be calculated as 232 ohms. Let us now put the Zener back in the circuit. With minimum input voltage of 8 volt and maximum load of 5 ohms, let us calculate the currents. We know that the series resistor is 232 ohms. With this, IE is given as V out by R2, that is equal to 1 amps. We know that IE is equal to IB into 1 plus beta. Then base current is IE by 1 plus beta. This results in 9.9 milliamps. Base voltage is given as VB is equal to V out plus VBE. It results in 5.7 volts. The series resistor current can be calculated as Is is equal to Vin minus Vb by Rs, which gives us 9.9 milliamps. Zener current Iz is equal to Is minus Ib, that is equal to 0 milliamps. The collector current Ic is equal to beta Ib, that is equal to 990 milliamps. With these known values, we can calculate VCE. VCE is equal to 3 volt. Let us now calculate the power loss in the circuit. We know the voltages and the currents in the components used. So, power loss can be easily calculated. Power loss in Rs is given as I square S into Rs, that is equal to 22.7 milliwatt. Power loss in transistor collector emitter junction PCE is equal to VCE into IC, that is equal to 2.97 watt. Power loss in transistor base emitter junction is given as VBE into IB, that is equal to 6.93 milliwatt. Total power loss in the transistor is given as PCE plus PBE, that is equal to 3 watt. Power loss in the Zener is given as VB into Iz, that is roughly equal to 0 watt. Total power is given as V out into IE, that is equal to 5 watt. With this, we can conclude that much power loss happens in the transistor. We can calculate the voltage, current and power loss in the components used when input is at its highest with minimum and maximum loads. Similarly, we can calculate the voltage, current and power loss in the components used when the input is at its lowest with minimum and maximum loads. The equation to calculate each parameter is as follows. IE is equal to V out by R2. IB is equal to IE by 1 plus beta. IC is equal to beta IB. VB is equal to V out plus VBE. IS is equal to Vin minus VB by RS. IZ is equal to IS minus IB. PS is equal to IS square into RS. PZ is equal to VP into IZ. PCE is equal to VCE into IC. PBE is equal to VBE into IB. Power loss in the transistor is equal to PCE plus PBA. It can be noticed that IS current is dependent on the input voltage. It is maximum at maximum input. Power of the resistor RS also depends on the input. Power is maximum at maximum input voltage. IB and IC is only dependent on the load. IZ and PZ are maximum when input is at its maximum and load at minimum. Transistor power loss is maximum at maximum input voltage and maximum load. In this video, we discussed how the series resistor can be selected for a given input voltage range and for a given load variation. We will learn more in our subsequent videos. Till then, let's keep exploring and learning. Thank you.